On Friday, you were announced to make sure and was on the board. It's also in Monday's digital day, being able to know where that is on Schoology and be able to fulfill your digital day responsibilities to watch your 7.5 notes. I will be collecting notes, and I'll be expecting that that 7.5 section is complete with all the things that are in the 7.5 notes. I would watch those notes. I wouldn't rush through them. Make sure you answer things that are in there and put down the things that are there because I'm looking for certain markings. Okay, so now about 7.5. I'm just going to run through some even problems just to bring you up to speed on what you're supposed to do, what you're supposed to get from those notes. If you've not done the notes take about 13 and a half minutes, 14 minutes to do. Okay, and then your assignment takes about 13, 14 minutes to do. Okay, both pages odd. Okay, maybe. So I'm just asking for about a half hour worth of work to give you credit for assignment from Friday and Monday. A half hour of work for 2 days of class. Okay, so if you don't have it done, mom and dad will be checking because they'll get an email tonight. And I am just assuming that the 35 people that did it, okay, are from my classes, all right, versus somebody else's. It's kind of very low and super disappointing that you guys had the amount of time that was provided and did nothing in some people's cases. Okay, make sure you're getting your stuff done. Little hearkening back to last week on the review and the quiz. Those people who did not do the review scored below 14 on the quiz. And they were the first ones to come up to me and say, hey, what can I do? I went, should have done the review. Okay, it's that matter of fact. Okay, if you're not getting the work done, your failure to prepare prepares one to fail. I mean, I'm a big believer in that. Okay, so just make sure you know that that's the case. Now, is that always the case? No, I have people who work their tails off and for whatever reason had a bad day on a quiz or a test. That happens. But on quizzes, we just move on. You know better, we just make sure we avoid those mistakes. Okay, so make sure you're getting your stuff done. Test is Friday this week. Today's the last day of new material. Okay, those people who have missed video captures, just like this one, have been placed in your notes. I mean, in your file for Schoology. You can find it there in Chapter 7 folder. Okay, so you're responsible for the material now. So let's talk about this. Let's look at 4. I know you weren't assigned 4 and 6. I'm not doing the ones that you were assigned. I am just doing some that are like some of the ones you were assigned, so that way you can go, okay, I'm on the right course or I'm not. 4, we're talking about side splitter. Side splitter extended to parallel lines. In order for side splitter to work, you must have parallel lines splitting sides of a triangle or parallel lines cutting up transversals like this one here. We're looking at A, and I don't know what it is, but I've got for the other one, excuse me, B to E. B to E is my other relationship. Opening to opening. Well, it must be D. Must be missing D here. So that's got to be D when I'm looking that over. Okay, and that's where it's at. Okay, as I'm looking on, using side splitter, in 8, x is to 12 as x plus 1 is to 15. Okay, the opening to opening stuff, and they've got this to this, this to this, when I'm working with my side splitter. Now, cross multiply. So I've got 12x plus 12 is equal to 15x. I subtract 12x and 12 is equal to 3x and x is 4. Okay, any follow-ups with that? Now I've got a couple folks that went, Bloom, I saw it this way. I saw it this way. Means exchange property. Totally works, right? We know it's a property of proportions. Totally gonna happen. The same 2 numbers are multiplied together. Yeah. It's funky. Okay. Yeah, we can talk about 11 as we're going through. I'll do the setup, but I won't finish. Okay. When you're looking at problems like problem 11, we're assuming that this is more like a triangle than anything else, right? So I've got a triangle going on there. Okay, I have x to x minus 2 as x plus 4 is to 9. Okay, now with the binomials, making a trinomial here, so that's really the question. It's not the setup probably. I've got 9x on the left, okay, and I've got x minus 2. I'm just going to talk about what I've got, plus 4. And I've got 9x equal x squared minus 2x plus 4 plus 2x minus 8. Okay, now when I get to something like this, remember we had those 2 days of review for FOIL, unfoil, zero product rule, working with the quadratic formula. These are why we did that. Okay, so in this extension of that day, I've got to get 0 on one side. Okay, I'm going to subtract 9x. So I got 0 equals x squared minus 7x minus 8. Okay, now I just factor. And two numbers that multiply to be 8 but add to be 7 are 8 and 1. Okay, one's negative, one's positive. You okay with that? 8 times 1 is 8, but negative 8 and positive 1 makes negative 7. So, you okay with those solutions on that? I'm writing really big. I'm not fitting in my stuff. I just want to make sure you're happy with my solutions. Yeah. Where are we talking about here? This is 2x. It is 2. It's plus 2 because it's negative 2 and positive 4. Okay, so it's positive 2x. I subtract 9 from it, and that's where my negative 7 is coming from. Although it's not unheard of that I make that, so just make sure you keep me honest. Okay, you all right with that? Because my inside and outside terms, my inside's negative 2, my outside's 4x. They combine to be 2x. Then I get my 7x, and now I have my zeros. So x is equal to 8, or x plus 1 equals 0, and x is equal to negative 1. At this point, I check, does negative 1 make sense? Negative 1 minus 2, that's negative 3. That's a value length of negative 3. It doesn't make sense for me to have that, so that's extraneous as far as my solution's concerned. It doesn't work. If I did not have a diagram, negative values are completely and totally okay to have. It's just I got to check it in the situation that I am aware of. Okay, does that help? Any other follow-ups? Now, sliding on to that next one, I did one like that. Let's talk about, well, this is side splitter in the triangle. I'm just going to do the setup. 4x plus 1, 8 to 20. Now, I want to emphasize something. When I set these up, I could reduce to make my life easier. 8 to 20 becomes 2 to 5. Are you okay with that? So I could multiply by 2 to 5 to come up with my same answer, because I just reduced a factor that's in common on that right side. Are you okay with how I'm doing that? We've done that with scale factor. I can totally do it here. And that is my scale factor, 2 to 5 in this problem, if I was wondering about it. Okay. Questions? Okay. Okay, sliding on to the next one. Let's go to that next page, I think. Oh, nope, 18. Here, determine whether the bolded segments are parallel. Now, side splitter assumes that they are parallel, and therefore the openings are proportional, okay? Well, if the openings are proportional, then the sides are parallel. That is the converse of the side splitter theorem. It might be a corollary that they might even mention it, because it easily follows, but it really is a converse of the original theorem. So if I'm looking at this, if this is true, then this should be true. If these are to be parallel, then that should be true, right? And if it is, those are parallel. So by the converse of the side splitter, the segments are parallel. Be okay with that. Okay. Now, next page. Checking those things out. Use the figure at the right to complete each proportion. I'm going to let that roll. We're talking about proportions with angle bisector theorem. I want you to make sure that you're careful with these. Today you're going to look at something called altitude to hypotenuse theorem. And you got to pay attention to notation to notice when to use certain things. This is angle bisector, and how I can tell is that these are showing as angle bisector. See, those are arcs, they're not right angles. Okay, they're showing them as arcs, being that those two parts are congruent to each other, you know, so the lengths are the same. But when I use this idea, okay, there's a couple ways I can set it up. I can set it up 16 to 12 is equal to x to 9. Okay, left to right on top, left to right on the bottom. I can also, and I want to make sure that you recognize this, because of means exchange property. Let me get rid of that circle so I can show you. Because of means exchange property, I can just set it up like that. Those are equal. The same side of the angle bisector ratio is equal to the same side of the angle bisector ratio. Okay, top to bottom. So I don't care which one you do. You got 12x equal 144, x is 12. Are there questions? We're doing okay? Makes sense? Okay, for the folks that did the notes, totally should. Okay, now I've got x plus 4 to 2x plus 3 equals x minus 2 to x. So I've got x squared plus 4x. If I cross multiply there, and I'm going to cross multiply here, equals 2x squared. That's my first. My outside is negative 4x. My inside is 3x, so negative x minus 6. I'm going to get everything over to the right. Okay, so now I have 0 is equal to x squared minus 5x minus 6. Two numbers that multiply to be 6, but add to be 5 would be 6 and 1. Okay, 6 and negative 1 specifically, but if I'm looking at, or excuse me, negative 6 and positive 1, as I'm looking at this, so negative 6 plus 1, and now I do x minus 6 is equal to 0, or x plus 1 is equal to 0. So those are my options, and now I know my answer is x equals 6 or x equal negative 1. I look at my situation. Can I have a negative 1 there? Doesn't make sense. So I'm going to not use that, but use that as my solution. Okay, that's why we did Monday last week. Okay, again, this one is on angle bisector theorem day. Okay, and you guys are just supposed to do the odds on the both days on the assignment. We'll correct those tomorrow. Okay, I'll have them posted around the room and you'll be able to check those out. Tomorrow is day 2 of 7.4, 7.5. It's kind of the start of your review because 7.4 and 7.5, the second half of the chapter test. We did a review on 7.1, 2, and 3 already, did the quiz. Your results of the quiz was your results of understanding on the first day of review. I would strongly recommend to people that did not feel happy with those results to go over that stuff because it will come back to haunt us on Friday. It's the same material on the test. Okay, so tomorrow we're going to have a recap on 7.4 and 7.5. Because of that, let's get, I just want to make sure I'm not skipping anything. Oh, 15 you got to skip. And, oh, and I want to talk about 13. I'm glad I went there. In problem 13, remember I showed you can set them up same side of the parallel, the angle bisector because of means exchange. Could I factor out an x? Wouldn't that make this nicer? Doesn't that make it a nicer problem? Wow, all of a sudden I'm almost done, right? Versus having the x in there. So know that if you have a factor, you can divide it out, okay? So be careful about that. With great power comes great responsibility, but you gotta skip 15 because I gave you a horrible problem. I apologize for that. Questions? Okay. Let's look at today's stuff. Today you're looking at something called altitude to hypotenuse theorem. If you take a right triangle and drop an altitude from the right angle, oh, and you guys, I'm sorry, you're on page 21. If you take an altitude and drop it across the right angle, from the right angle to the hypotenuse, it splits the triangle into 3 similar right triangles. But let's talk about a right triangle. Right triangle is contains one right angle. That's angle ACB here. The side opposite that right angle is the hypotenuse, segment AB. Now, the other 2 sides are segment AC and segment CB. Those are considered legs. Legs make your right triangle's right angle. The legs of a right triangle make the right angle. Okay, maybe perhaps I'll talk about these are legs. This is hypotenuse. Okay, now the altitude to hypotenuse of a right triangle divides the triangle into 2 triangles that are similar to the original. So if ABC is a right triangle with a right angle ACB and CD is the altitude to the hypotenuse, they're talking about CD. This is the altitude to the hypotenuse. It's splitting up this triangle. Then I have 3 triangles resulting, and all 3 of those triangles are similar. Okay. One of the things that's cool about this is that they're really similar, not just because the sides are proportional, but because of angle-angle similarity. When I drop this, I have this right angle. This angle here, angle B, is the same as angle B in triangle ACB and the same in triangle CDB, and similar, or the same angle I should say, in the similar triangle ADC. So this angle are all the same. Okay? In this triangle, the acute angles are going to be similar according to the color I just popped in there. All right, they're congruent, so therefore it makes the triangle similar. Are any questions about that? So I'm working with 3 similar triangles. I do not want you to be a mental gymnastics flipper of triangles. It's not the purpose of this section. Although this is what happens. This triangle comes over here, we flip it, and it comes into that other spot. That's where that one's from. This one comes over here, and I'm going to show you the flip here on this one. Both of them would flip after I fix them. And then I do a flip, maybe, up and down. And that's the triangle where it came from, okay? Now, please write down the 3 similar triangles. They are all related. Now, remember this bigger triangle is triangle ZXY. That's where it's all from. I'm just showing you ZXY, the big one, is similar to the other 2. Okay, so make sure you recognize where they're all from. And again, I do not have to have you be a mental gymnast. Okay, you don't have to be flipping things around. Besides, it's not summer Olympic time, it's winter Olympic time. Okay, no gymnastics. With that said, we're skipping problem 2. I want to go to geometric mean. Now, why is this all of a sudden there? Geometric mean is a situation in where I take 2 numbers, I multiply them together and find their square root, okay? This is really what it comes down to. Cross multiply, take the square root. Now, you can do this in your calculator, but I'm going to expect you to do it as exact answers. Remember exact answers? You guys, y'all did it last year, November, December, January, and Expo. Okay, I'm bringing it back. Okay, so as a reminder, let's talk about a few things. First of all, if I have 2 factors, and I'm just going to step aside, if I have 2 factors, and I'm taking the square root of c squared and d, okay? I know c squared is a perfect square. I take out that largest perfect square, and I can multiply them like this, with the intent of pulling that out and extracting it so it's c times the square root of d as my answer. That's an exact answer. D has nothing as in common with a perfect square factor. C did. I pulled it out, took the square root, and I list it as my answer that way. So let's see what it looks like with actual numbers. So I'm looking at x is equal to 6 times 15. That is equal to the square root of 90. Some of you are looking like, well, you know, that's 9 times 10, Bloom. All right, that's a good place to start because 9 is a perfect square. Now, are there any other factors that are perfect squares inside 10? And folks are going, what do you mean inside 10? What makes 10 as far as factors are concerned? And you're all thinking 2 and 5. 2 isn't a perfect square, 5 isn't a perfect square, and 2 and 5 are not the same number. So 10 doesn't have any more perfect squares inside of it. We're done. Square root of 9 is, yeah, 3 to the square root of 10 is my final answer. Okay, that's it. Now, it's your turn. You guys do B. That's all we're doing. Get her going. Get her a try. Factors of 120. And folks are like, well, I don't know. Let's make it easier. Factors of 12. What are factors of 12 that are perfect square? 4 and 3. Well, to exchange that with 120, I've got 4 times 30. Now I have some people go, yeah, but Bloom, inside 30 there might be some stuff. Yeah, there might be. There are 5, a 2, and a 3. Are any one of those repetitive factors of the same number? 5, 2, and 3. Nope. So 30 isn't a perfect square. And it does not have any perfect square factors inside of it. So I'm going to take the square root of 4, the square root of 30, and I have 2 the square root of 30 is my final answer. Now, sometimes it's better to factor before you multiply, okay? Because I like factoring smaller numbers, and everybody I know factors smaller numbers faster. And case in point, when I'm doing problems like this next one, although this is true, and it's 80, I can break it down this way. 20 is 4 times 5 times 4. I leave 4 that way because it is a perfect square factor. And are you happy that 4 times 5 is 20? No, what's 4 times 4? A bigger perfect square, but it's 16. So I can take the square root of 16 times 5 and do the square root of 16, the square root of 5, and be done this way. Now, some of you may have just saw, hey, it's 4 the square root of 5 because you saw it, and that's okay. But I want to make sure I generated why I did what I did when I did it. Sometimes multiplying them together makes sense. Sometimes it doesn't. And the more often we do it, the better feel of it you guys will get. Okay, why did I factor that one versus the next one? I know something about 4. 4 to the 3rd power is a perfect cube. That also is, incidentally, a perfect square. And people are like, what? 16 times 4? 64. Okay, so on this one, I got 16 times 4, square root of 64, that's just 8. Okay, and that's why I look at that one. I'm going to multiply that one because it makes a perfect square. Okay, and then I'm done. Couple things about perfect square though, and I want to make sure it's clear. Once you apply the perfect square, you take the square root of something, you're done. Even if the answer's a perfect square, you don't do it again. Once you apply the rule, you know, I'm taking the square root. Okay, once I do it, I'm done. I don't repetitively do it until I break it down because that would be akin to this. Say I went 3 plus 3, or 2, right? 3 plus 2, 5, right? It's not 7. It's not 9. It's not 11. It's not 13. It's not 15. It's not 17. We just add it once. Once we do the operation, we're done. So once I take the square root, I'm done. I do it once. Okay? Now, sliding on to page 23 in your notes. And I'm doing this because we're bouncing around a little bit because I wanted to make sure this is as streamlined as possible for the basic stuff you need to get what we're doing today. Okay? It's not about missing other stuff. I've actually covered the stuff we're missing. Okay? Now, we're doing formations. And when I'm talking about formations, we see formations. I could put X's and O's up here. I could put a little circle around the X is supposed to be the center, and everybody would find the quarterback. Everybody find the backs, find the linemen and everything. Okay? We're used to seeing plays, or in this way, this result, a formation. But I want you to be careful about something. When we did this altitude to hypotenuse theorem, we're dropping an altitude from the vertex of the right angle to the hypotenuse. That is letter A when we do that. Okay, that's the altitude. That's A for the altitude. When we cut that hypotenuse into two parts, and remember this is the hypotenuse H. When we cut the hypotenuse H into two parts, we refer to them as part 1 and part 2, but instead of part, we're talking, well, you know, really it's a segment. Okay, because it's got a measure. So this is segment 1 and this is segment 2. That's why we do the subscripts for the two segments. So segment 1 and segment 2, we add those together, we can get the hypotenuse. Okay, if I know one of them, I can subtract from the hypotenuse and get the other. Remember the legs, leg 1, leg 2, they're script L's. They make my right angle. Those are my legs. Every time I come up to a right triangle, I'm thinking about, and I'm going to do it down here. This is leg 1, this is leg 2, this is S1, this is S2. This whole thing is my hypotenuse, okay, and this is my altitude. I look at the formation, and then I can only run 3 plays off this formation. Corollary 1 is one play, corollary 2 is another play, and corollary 2B, I guess, is another play. How do I determine which one's which? Based on personnel I have out on the field, okay? So I've got to base my search for this with personnel. Let's say we're going to find X. X is located in the L1 position. Are you okay that it's located in the L1 position? Which one plays L1? Which one of the plays has L1 in the playbook? Corollary 2, the first one. Does that make sense? That's why I'm grabbing that one. It's not in corollary to the B version or in corollary A. So I am totally going to get this a little higher, make sure we can see everything, and plug in my numbers. So X plays L1. H is 4 plus 12. Do you see how I'm getting H is 4 plus 12? My S1 and S2, the two segments that make my hypotenuse, that's 16. L1 is X. L1 again is X. And I found S1 is 4. That's how I read my playbook and decide what I'm going to do. I have a formation. I look at what players are available to play, and I look at the plays that I can play off that formation. Okay, so formation's always the same. The 3 plays are always the same. My players can move around in the formation, but I got to make a determination based on their positions what I can do. Okay, at this point after my setup, I've got x squared equals 64. Hey, this was pretty nice, right? Take the square root of both sides, x is 8. You okay with what I'm doing? Now, check out where y is playing. Again, I'm going to go over the formation. I'm going to talk about where y is playing. I got L1, I got L2, I got A. I've got S1, I've got S2, I've got H. Now, the reason why I'm doing this is because I want to make sure you all know it's going to be in the same spot every time. The altitude splits. My S1 and L1, they got to play on the same side as the altitude. Whatever the altitude is, S1s, the ones are on the same side of the altitude, cutting it in half. The twos are on the same side, okay? Now, S1A, well, gosh, S1A, that's this one. This is the only one that's got A on it, right? The other ones don't have A on it. They have S1 and stuff. But that's what's determining which one I grabbed. So I've got S1 and I've got A. So I got S1 is 4, A is Y, S2 is 12. And now I've got this formation and I play it. Take the square root. Y is equal to the square root of 16. The square root of 3, by the way, that makes 48. And the square root of 16 is 4. Now I've got some folks going, geez, how do you do that? 4 plus 8 is 12. And 12 is divisible by 3. So if you add the digits of a number up and their digits that you sum are divisible by 3 or 9, the number is divisible by 3 or 9, okay? So that's how I did the check. I went 4 plus 8, it's 12. Boom, I'm gonna use 3. And then in doing so, I found out that 16 was a perfect square in there, okay? Now, I could have also, are you guys familiar with factor trees? Breaking it down by factors, the ones on the left are just the prime factors. And then the ones that are pairs or perfect squares, I got 16 times 3. So there's a bunch of ways you can line up how you do this. Grab one, work with it. Maybe there's one that's worked before, but it's always about the largest perfect square and put it by itself and take its square root and then the rest of it, okay? It's your turn. Y'all have a play to do. I want you to find X and I want you to find Y. Remember, Y is there, X is there. Determine which play you're going to do out of the formation that's provided there. Give it a try. Some people are done, some people aren't. So you're going to go find your X and Y out of problem 15. Or 5, excuse me, 5. Yeah, that one, that other 5 number. Now here's the deal. X is playing in the L1 position. Left to right. People are like, do you always number it this way? I always go left to right when I approach them. Okay, it makes my life easier. I think, hey, the hypotenuse is made up of 2 segments that's cut up by the altitude. The altitude is always A. Okay, so X is playing the L1 position. Well, that was the same one we were playing with before. And when I use L1, I've got to use S1. Are you starting to notice the things that are with L1? Okay, they're like pals that hang out together during the play. So I got 4 plus 5, that's 9, that's my H. My L1 is X, well, X is repeated again. S1 is 4. Now I got X squared equal 36, and X is 6. Now, finding Y. Y is A. The only one that has A is S1A, AS2. So S1 is 4, Y, Y, 5. Y squared equals 20, and Y is equal to the square root of 5. Hopefully that's going well for you. Are there questions? Okay, next one. Maybe, perhaps, if the board lets us. I want you to take and find the geometric mean of 7A and 7B. Go ahead. 7A and 7B. I'm skipping around a little bit. We're going to come back and fill in some gaps tomorrow, or the ones I really feel you need, and then we'll move on from there. This freaks people out when I do it this way, but they also are freaked out that I factor things really fast. And they're like, how did you do that with that big number? It's like, I didn't do it with the big number. I did it with the small number, okay? So 12 is 4 times 3. Are you all in agreement? Why did I pull out the 4? It's a perfect square. 4 is a perfect square. 2 perfect squares multiplied together make another larger perfect square. Now I got the square root of 16, the square root of 3, and this is just 4, the square root of 3. Makes it real fast for me to be able to organize it that way. It is way easier to break up perfect squares in the factors I'm working with. Okay, and I'll show you some that when I can combine other factors, some other things will happen when they come up. But 4 times 9, both of them are perfect squares. 2 and 3, I've got 6. I'm loving it. I'm done. Because that's the square root of 36. You okay with that? It's always with chocolate milk when you make bubbles. No bubbles with those. That'd be bad. It's always chocolate milk bubbles. Okay. We're skipping that. We're going to 15 through 20. And that is on page 24. 15 through 20 on page 24 is our assignment today. 15 through 20 on page 24 is our assignment today. I know we have some other stuff going on, but I'm planning for making sure all your 7-5 stuff is done, including your notes and assignment. Okay, has to be done tomorrow because I'm just assuming I'm moving on with life. You have 6 questions today. Okay, you might have to find X and Y in a couple of them, but it's the same stuff we've just been doing. If you have questions, make sure you ask them, but these are the 6 questions that I'll do right away at the beginning tomorrow, and then we'll venture out and do a couple more things. Are there any questions? Awesome. Okay, go ahead. For those folks at home, you guys got the same thing, 15 through 20. And then when we get back tomorrow on campus, we'll go through those. And we will go through a select number of problems for the 7-4 assignment tomorrow right away. And then we will do a little review of 7-4, 7-5 assignment. And then on Thursday, we will have the day 2 review for the whole chapter because Friday's your test. So keep that in mind. That's the pace for the week. Have a great day.